This video looks at solving basic linear equations. So I will be looking at what we call one-step and two-step linear equations. So linear equation has, first of all, a linear equation would look like something like this. This could be a linear equation. This could be a linear equation. Because the variable, or the unknown x, which we'll talk about shortly, is to the first power. So these are linear equations. A nonlinear equation would be something like x squared plus 5 equals 7. The square root of x minus 4 equals 2. So here x is to the second power, and here we're taking the square root of x. So these are non-linear. Linear equations turn out to graph in straight lines, but we're not talking about that in this video. So x, or whatever unknown we have, will be to the first power, because x is the same as x to the first. This means x multiplied by itself one time, which is just x. So first of all, the idea of an unknown, I mentioned that just a moment ago. So 3 plus box equals 10. Most students already understand what that means. That is, what goes here that I add to 3 that makes 10? Well, we know that's 7. And I can think of the box as a storage space. In this case, it must take a particular value, but initially I didn't know what that was, so I call this an unknown. Now, instead of using a box, we could use a letter like x to represent our unknown storage space. And this is what we usually do. So 3 plus x equals 10 is the same thing as 3 plus box equals 10. In fact, you could use any symbol that you like here. I could have 3 plus smiley face equals 10. 3 plus the Greek letter psi equals 10. 3 plus the Greek letter alpha equals 10. In all cases, box here equals 7. Here x equals 7. Here smiley face equals 7. Here psi equals 7. And here alpha equals 7. So an equation is like a balance or teeter-totter. The equal sign means that both sides are in balance. They are equivalent. So if I did something to one side and didn't do to the other side, it's going to go out of balance one way or the other. Either the teeter-totter is going to slant this way or it's going to slant this way. But with an equation, we don't want that to happen, because then we're changing the value of x, our unknown. In this case, we're using x for unknown. So if I have 3 plus x equals 10, to remain in balance, what do I do to the left side? I must do to the right side. So for example, if I add 7 to both sides, which I'm allowed to do because it'll still be in balance, I would have 10 plus x, and here I would have 17. So after adding 7 to both sides, 3 and 7 makes 10 plus x is 17. Now, at this point, I still don't know what x is. Well, in this case, you can kind of see what x is. It's going to be 7. But that really doesn't help me solve the equation. So while I can do whatever I want, as long as it is done to both sides, what I want to do is I want to do things that help me figure out the value of x. And to do this, I want to do things that isolate x by itself. So in our particular equation, 3 plus x equals 10, I want to isolate x by itself. So I will take 3 away from the left side, but if I take 3 away from the left side, I have to take it away from the right side also. So notice here I can say 3 minus 3, put those together. That's a 0. And then I'm left with x. So I'm left only with x here. And then 10 minus 3 is 7. Now I have a direct solution. The value of x has to be 7. So in solving linear equations, I have a little list of things that we need to do. So whatever you do to one side, you must do to the other side. Number one. Number two, you're trying to get x, or whatever unknown you have, all by itself. And you can reverse the order of operations rule PEMDAS to solve equations, which I call SADMEP. So the order of operations is parentheses. So PEMDAS stands for parentheses first, that's P, 2 exponents, you do exponents next, 3 you do multiplication division, that's the MD, from left to right, working left to right, 4, and last you do addition subtraction from left to right. So there's your PEMDAS. Well, when we solve an equation, we actually undo addition subtraction first, and then undo multiplication division. So we reverse the process, which is why I call it SADMEP. So now let's solve some equations. Well, first we'll talk about the reciprocal of a number. So recall that other than 0 or 0, which is not allowed, because division by 0 is not allowed in mathematics, a number divided by itself equals 1. So for example, 7 divided by 7, or 7 over 7, is equal to 0.8 over 0.8, which equals pi over pi, which equals 1. If you flip a number over, you get what's called the reciprocal. So reciprocal is what you get when you flip a number over, upside down. So 1/7 reciprocal is going to be 7 over 1. 4/13 reciprocal is 13 over 4. Now 4, to make the reciprocal, I first have to write as 4 over 1, because 4 equals 4 over 1, because 4 divided by 1 is 4. So the reciprocal is 1/4. Now 0.8, that looks interesting. Well, if you know that 0.8 is actually 8/10 by definition, and you can divide 2 into both 8 and 10, so that reduces to 4/5. So reciprocal of 0.8 is 5 over 4. Then 1 2/3 is a mixed number, so what I need to do for a mixed number is change it to an improper fraction. So I go 1 times 3 plus 2 over 3, which is 5/3. So reciprocal of 1 2/3, which equals 5/3, is 3/5. So reciprocal of numbers, the property of a reciprocal number is other than 0, multiplying a number by its reciprocal equals 1. This is technically called the multiplicative inverse property. So 1/7 times 7 over 1 has to equal 1, because you can treat this as, when you multiply fractions, that's 1 times 7 over 7 times 1, and 7 divided by 7 is 1, and 1 divided by 1 is 1, so you just are left with 1. And 4 times 4 over 3 is the same as 3 times 4 over 4 times 3. However you want to slice or dice it, that's 12 over 12, which equals 1. You could have also done this one this way. You could have said 1 times 7 is 7, 7 times 1 is 7, and that equals 1. There's different ways to look at this. You could cancel here the 2's and the 1's, you get 1 over 1, or say this is 2 over 2, which is just 1. So multiplying a number by its reciprocal is equal to 1, and you'll see in some equations that we solve, that'll be a useful property. So let's solve some equations. So solve for x. So remember, we're using SADMEP. And we want to isolate x by itself. So if I have 3 times x, I want to isolate x by itself. So this is multiplication here. So to undo multiplication, I use division. So I'm going to divide both sides by 3. So now my 3 divided by 3 is 1. That leaves me with 1x. But 1x is x, because anything times 1 is itself. So this leaves me with x equals 6 over 3, but 6 over 3 is 6 divided by 3, which is 2, so x is 2. And if I want to check my answer, I go 3 times 2 is 6, and that checks out. So my answer here is 2. So next question, 1/8 x is 3. Well, what I'm going to do is I want to isolate x. So one way to do this is, okay, take the reciprocal of 1/8. So if I multiply both sides by the reciprocal of 1/8, and the way I'm going to do this is put a set of brackets around this and multiply by 8/1. Now I have to distribute this 8/1 to both sides, and 3, remember, 3 can be written as 3/1 because 3 divided by 1 is 3. So I'm going to write this as 3/1. And now 8 times 1/1 times 8 is 8/8, which is 1. So I'm left with just 1x, or x equals 3/1. But actually that's not 3/1. I almost made a mistake myself. So here I'm multiplying now 8/1 times 1/8x. But then I'm also distributing the 8/1 times 3/1. So x equals 8/1 times 3/1. So x is 24/1, but 24/1 is just 24. So my answer is 24. To check my answer, I take 1/8 times 24. Well, that's the same as 1 times 24. That's the same as 24, the same as 24/1. So that's 24/8. But 24/8 is 24 divided by 8, which is 3, which is what I get. So the answer checks out. Another way to do this problem is 1/8 x is the same as 1x over 8. So I can just write this, though, as x over 8. So another way to do this problem is write this as x over 8 equals 3, and then just multiply both sides by 8, because this is 8x divided by 8, and to undo division, I can use multiplication. So now I distribute the 8. I multiply 8 times x over 8 and 8 times 3, but 8 divided by 8 is 1, so I'm left with x equals 24. So that's another way to think about that particular problem. So now the next question, I have 9 equals 2x. In this case, x is on the right side equal sign, but it doesn't make any difference because you can swap things around the equal sign. It doesn't change anything. So if a equals b, for example, that means b equals a. So I could write this as 2x equals 9, but I'm just going to keep it as is for now. So I have 2 times x. To undo multiplication by 2, I use division by 2. So I have 9 halves equals x. Or, since I can swap around the equal sign, x equals 9 halves. And swapping around the equal sign, by the way, is called the symmetric property of equality. So x is 9 halves. We could also write that as a mixed number by dividing 2 into 9. 2 goes to 9 4 times. 4 times 2 is 8. So I could write this as 4 1/2. So either answer is correct. If I wanted to check my answer here, I start with my original equation, 9 equals 2x, and plug in 9 halves. So 9 equals 2 times 9 over 2. Well, you see this works because 2 times 9 is 18, divided by 2 is 9, which is what I need to get here. So in the next example, 3/4 x equals 9. So what I'm going to do here is I'm going to multiply by the reciprocal. I want to isolate x, get it by itself. So I'm going to multiply both sides by the same thing. Remember, in an equation, what you do to one side, you must do to the other side. So I'm going to multiply both sides by 4/3. So 4/3 times 3/4 is 1, so that leaves me with x equals 4/3. Now I need to multiply the right side by 4/3. So that's 4/3 times 9. But 9 is 9/1. 9 is the same as 9/1. Well, this is the same as 36/3, which is 12. Or you could reduce it first. 9 divided by 3 is 3. Any way you slice it or dice it, you get 4 times 3 here is 12. Any way you do this, you're going to get x is 12. And you can check your answer. So if I put in 12 for x, I have 3 times 4/4. That's 36 divided by 4, which is 9. So that checks out. Okay, now we have some what we call two-step equations because we have to do two things to solve the equation. So remember, SADMEP First thing you undo here when you have multiplication, addition, subtraction, is you undo the addition, subtraction first. So what I'm going to do is I'm going to subtract 5 from both sides. And I also want you, when I've been doing these, notice I keep my equal signs lined up. In all these questions I've been doing, my equal signs have been lined up, and that's what I want you to do. So now bring down to 2x. 5 minus 5 is 0. You don't have to write anything there because 0, you don't need to put anything there. And 18 minus 5 is 13. So now I have 2x equals 13. I have multiplication of x by 2. To undo multiplication, I use division. So I get x equals 13 over 2. You could also write that as a mixed number. 2 goes into 13. Well, 2 goes into 13 6 times. 6 times 2 is 12. So as a mixed number, this is 6 1/2. So my final answer is 13 halves, or 6 1/2. So if I want to check my answer here, I would plug in 13 halves for x. Well, 2 times 13 divided by 2, the 2's cancel out, so I'm left with 13 plus 5 equals 18, and that checks out. So in the next example, I have to isolate x. I have to do the same thing to both sides, and I need to use SADMEP. So I undo addition, subtraction before anything else. So to isolate x, I need to get rid of the 6. So I'm going to subtract 6 from both sides. First, bring down my equal sign. 6 minus 6 is 0. Bring down to 3x. 21 minus 6 is 15. Now I have 3 times x is 15. Well, to undo multiplication, I use division, so I'm going to divide both sides by 3. The 3's cancel. I'm left with x is 15 over 3, which is 5. So my answer is x equals 5. To check my answer, I plug in 5 for x, so I have 6 plus 3 times 5 equals, well, that's 6 plus 15, which is 21, so that checks out. Okay, the next question, I have x over 4 minus 5 equals 10. Well, again, we're using SADMEP. Again, what we do to one side, we must do to both sides, and we're trying to isolate x. So first thing to get x by itself is get rid of this plus this minus 5. So I'm going to add 5 to both sides. Bring down my equal sign. 10 and 5 is 15. Minus 5 plus 5, those are opposites. That's 0. And bring down the x over 4. Okay. So now I have x divided by 4 is 5. Well, to undo division by x, I use multiplication. So I'm going to multiply both sides by 4. So 4 divided by 4 is 1, leaving me with x, or 1x. And then 4 times 15 is 60. So my answer is 60. If I check my answer, I have 60 over 4 minus 5 equals what? Well, 60 divided by 4 is 15. 15 minus 5 is 10, so that checks out. In our last example, I have 2/3 x plus 2 is 8. I'm solving for x. So, again, using SADMEP, again, I'm trying to get x all by itself, and what I do to one side, I must do to both sides. So first thing is I got to get rid of this 2, so I'm going to subtract 2 from both sides, because I have plus 2. To get rid of plus 2, I subtract 2. So 8 minus 2 is 6. 2 minus 2 is 0. And I bring down to 2/3 x. So that's step 1. Now, to get rid of 2/3 x, I will multiply by the reciprocal, which is 3 halves. You need to multiply both sides by that reciprocal. So 3 halves times 2/3, that's 1. So that leaves me with x equals, now I have, on the right side, I have 3 halves times 6. Well, 3 times 6 is 18 divided by 2. 18 divided by 2 is 9, so my answer is x equals 9. Then finally, to check my answer, I take 2/3 times 9 plus 2 equals 8. Well, that's 2 times 9 is 18 plus 3. I'm sorry, 2 times 9 is 18 divided by 3 is 6, and 6 plus 2 equals 8, so this checks out. And this concludes the video.